Welcome back to my channel. Here we are still working on the construction of polygons, and we have started with the construction of hexagon. The first one that we did, so which is this two that we use, these two methods. We are given the length or side of the hexagon. So now, so we are going to have another two methods with different information. Okay, so for the first one that we are going to do, we are given the distance across corners. We are given the distance across corners. We want to construct an hexagon when we are given the distance across corners. So let's say the distance across corners is 60 millimeters. The distance across corners that we are given is 60 millimeters. So how can we construct this hexagon? So let's see how that can be done. All right, so what we are going to do here first, we are going to draw a horizontal center line. So horizontal center line. So we have this to be a horizontal center line. So we have this horizontal center line. Okay, so then we are going to draw a vertical center line. So we also draw a vertical center line like this. So here we have the vertical center line. So we have it here like this. Okay, so this is vertical center line. The next thing that we are going to do is that we are given the distance across corners to be 60 millimeters. So we take the compass and we take a measurement of 30 millimeters. Divide that distance across corners given to you by 2. So 60 by 2 will give us 30. So we take a measurement of 30 millimeters on the ruler with the compass. So this is my 30 millimeters here. So this is 30 millimeters. So you put the pinpoint of the compass here at this point. Then you draw a circle. So draw a circle like this. So here we have this circle. Okay, so then the next that we are going to do is that with the same radius that you used to construct the circle, whose radius is 30 millimeters, which is half of the distance across corners that you are given. So leave this 30 millimeters as it is. So put it at this point. Okay, put at this point and make an arc up and down. Okay, then you put at this point, make an arc up and down. And then if you don't want to do that on this line, or you don't want to do that, make use of this line, you can put it here. Okay, you can put at this point, make an arc right and left, and then do the same thing on the from here. So make an arc right here and left here, and then we are going to join the point together to form a hexagon. But for me, I want to make use of this point, okay, on the horizontal. So I will make an arc up here. Okay, so make an arc up here and then make an arc down here like this. And then so put the pinpoint here at this point here. So make an arc up and make an arc down here. So I made use of the point here and here on this horizontal center line. Okay, so if you have made use of the point on the vertical center line here and here, so you get something, you still get the same hexagon, but the way to be turned be different from the way this is turned. So please take note of that. So now, so we are joining this point together. So let's call this point, this is point A here. Okay, so here is point B. Okay, so then we have this point to be point C. So this is point D, this is point E, and then we have this point to be point F. Okay, we have this. So we are joining this point together. So we join this point AB together with a straight line like this. So we have this now. Okay, then we join this point BC together with a straight line. So we form this side of the hexagon. So join CD together and form another side of the hexagon like this. Then join DE together, so to form another side of the hexagon. So we have this, and then join EF together to form another side of the hexagon. Then we join AF together to form the sixth side of the hexagon. So this is hexagon, so in which we are given the distance across corners. We are given the distance across corners. So distance across corners is distance from here to here. Okay, so which is the diameter of the circle. Okay, so if you are given the diameter of a circle and you're asked to construct a hexagon, you still follow the same method. So let's say the diameter that you are given is 60 millimeters. So all you have to do, divide that 60 millimeters by 2, and then so you have drawn this line, draw this line, and then put the pinpoint here, and then draw a circle. Then, as I said, put the pinpoint here with the same radius, make an arc up, make it down, then put at this point, make an arc up, make it down, okay. Then if you don't want to use these 2 points that we have on the horizontal, you can make use of this point here on the vertical center line, and then this point here to get the arcs, and then you join them together and form a hexagon like this. So the length or side of this hexagon is equal to the to half of the diameter of the circle, or half of the distance across corners that we are given is the length of this hexagon, so which is 30 millimeters. All right, so let's go and see another method that we can use to construct a hexagon. But in this case, we are given distance across flats. We are given distance across flats. Okay, you know that for this one, we are given distance across corners. Now we are given distance across flats. So what are we to do to construct a hexagon? So let's say the distance across flat that we are given is still 60 millimeters. The distance across flat is still 60 millimeters. So let's see how that hexagon can be produced. So what we are to do now, we are going to draw a horizontal center line. So we draw a horizontal center line here. So here we have a horizontal center line as we did for the one up there. Okay, then we are going to draw a vertical center line. So we draw a vertical center line here. So I need more space on this side. So we draw a vertical center line here like this. Okay, so here we have a vertical center line. I need to extend this line a bit to this side. So we have this now. So then the next thing that we are going to do is that we take a measurement of 30 millimeters on the ruler, which is half of the distance across flat that we are given. As I said, that the distance across flat given to us is 60 millimeters. So we take 30 millimeters, half of the distance across flat that we are given. So this is 30 millimeters here. Then put the pinpoint on the compass here where the two center lines intersect and draw a circle. So draw a circle like this, okay. So draw a circle as I've done it here. So here we have the circle. Then the next thing that you are going to do is that take your pen or your pencil. So bring this T-square to this, let it touch the circle a bit, okay. So we want to draw a tangent, okay, a tangent to this circle or to this part of the circle, and it goes like this. So just draw it like this, okay. So draw it like this to this side, and then come up here and do the same thing. So make sure you can see a little part of the circle up here, okay. Then draw a tangent to this point on the circle. So draw it to this side, and then the next thing that we are going to do is that we take our 60 degrees set square, so this side of the set square, okay. So bring it here, set on the T-square, and bring it close a little bit to the circle. So we are going to draw a tangent. So we draw a tangent from here. So let it touch this line, and then let it touch this center line, okay. Then bring it up here. So just bring it up here. So slide it up here. Make sure you can see the circle a little bit, and also so draw a line like this, okay, to touch this, okay. So we have this now. So then the next thing that we are going to do is that, so with the same 60, so with the same 60, so just bring it a bit close to the circle, and then draw this line. So draw this line, so it goes like this, okay. So we have this, okay. Then so come up here. So come up here, and then make sure you can see a little part of the circle and draw this line. So we have this, okay. All right, so we have the hexagon as you can see it here. So if I label this point, so I'm going to call this point, this is point A here, and then this is point B, okay. So here is point C, and this is point D, okay. So we have this point to point E, and this is point F here. So I want to make lines, I want to make them thick so that we can see it very well. So just make this line a thick line, and then make this line a thick line from here to here, okay. Then so make this line a thick line, so like this, okay. Then so also make this line a thick line from here to here, and then we also make this line a thick line from here to here. So then also this line AB, make it a tip line from here to here. So here we have the hexagon in place. So we make use of this method for the construction of a hexagon when distance across flat is given to us. So where is the across flat? So if I draw a line from here to here, so if I draw a line, so through the center of the circle, and it touches this flat side, okay, just let me do it this way. Okay, so let me set it on the, so I draw a line from here to here like this. Okay, you can see that it touches the flat side, like this. Okay, so this is the distance across flat. So we write it like this. So we write distance across flat here like this. So we have a, okay, slash f. So distance across flat is slash f. Okay, then distance across corners, let me also show it here. For distance across corners, I can just connect these two corners together. So it goes like this. So connect these two corners, connect them together with a straight line. So we have this. Okay, so if I so make an arrow head here, okay. So if I write here, so in this case, so this will be a slash c, so that is distance across corners. So we have the two methods that you can use to construct the hexagon. The first one here is that when you are given a distance across corners, while the second one when you are given a distance across flats. It's as simple as I've done it here. All you have to do is to practice. Thank you, keep on practicing, and God bless you.